Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the combination of circuits. In fact, combination of elements in a AC circuit, which means that in the previous videos we have discussed about the pure resistive circuit, pure capacitive circuit, and pure inductive circuit. Now, in this video, we'll be discussing about their combinations. So here, in the first case, we are talking about this combination, which is a combination of R and C. So in this case, you can see first of all that if there is a voltage drop across this resistance, which is termed as VR, and the voltage drop across this capacitance is termed as VC. So first of all, and very important thing is the fact that we cannot write V as VR plus VC. This is absolutely wrong. This is wrong because uh, these voltages are not in same phase. VR and VC are not in same phase, but in DC, in when the battery was connected at the place of this oscillator, we could write it as V is equal to VR plus VC because it was correct in that case, because in DC circuits VR and VC will be in the same phase, but here we cannot. So now let us discuss that what will be the correct relationship between VR, VC and V in this case. So to derive the correct relationship in this case, we have to draw the phasor diagram first of all. So let us draw the phasor diagram. So to draw the phasor diagram, we always assume the moment of time as t is equal to 0. First of all, let us draw the curves. So these are the curves. Okay. And let us assume that at t is equal to 0, we are drawing this phasor diagram. I'll write down at t is equal to 0. Now, at t is equal to 0, we can see that this is a series circuit. And in the series circuit, current will remain same. We know that current remains same in the series circuits. So, we have to draw the current on x-axis because current is the reference for both of them because it is same for both of them. And we know that capacitor says that in my circuit current will dominate over the voltage in phase by pi by 2. So we can easily say that if current is on the x axis, then the voltage across the capacitor, which is VC, will be drawn on the negative y axis. This is VC, and VR will be drawn on this line, x axis. The resultant voltage V will be this, and this angle will be phi. So V in this case will be added by vector addition, and we know that according to vector addition, V will be equal to VC square plus VR square. And obviously, see, first of all, let us talk about tan phi also. I'll write with the same ink. Yeah, first of all, let us talk about the tan phi. So tan phi, you can see that it is VC by VR, and VC can be written as IXC and VR can be written as IR. So cancelling I with I, tan phi will be equal to XC upon R, and XC upon R can be written as 1 upon omega CR. This is tan phi, and this phi represents the phase difference between current and voltage. Still, you can see that current is leading the voltage because this circuit has capacitance and resistance. So there will be symptoms of capacitive circuit, and capacitive circuits says that current will lead the voltage by pi by 2, but that is in the case when the capacitance is pure, but here capacitance is not pure. There is some resistance also present in this circuit, so we can say that this phi will not be pi by 2, but it would be greater than 0 and somewhere between pi by 2 and 0. Now what will be V? So V can be written as under root of VR square plus VC square. This is by the vector laws, and obviously we can say that these two will combinedly oppose the current, and their combined opposition to the current will be called as impedance. So, impedance is a general term which we would use to refer the opposition offered by any combination of elements RC, LR, RC, uh, LC, or LCR. Any combination of these elements offers some opposition to the current, and that opposition is named as impedance in all the cases. So it is impedance and it is denoted by the symbol of Z. So it is, first of all, it is impedance, and IZ will be under root of VR. VR is IR and VC is IXC. So cancelling this I with I, Z will be equal to under root of XC square plus R square. This is Z. And this is the impedance, and we can write XC as omega 1 upon omega C. So this is Z. And we can also find out the value of peak value of current. So I naught will be V naught by Z. The dimensions of Z and the unit of Z will be ohms, because it is the resistance only, but it is termed differently here. And in the place of resistance, we'll be using this Z in the combined circuits. So I naught will be V naught by Z, and the current will be equal to I naught, which is V naught by Z, sine omega t. Now you can see that the current is still leading the net voltage. This net voltage V is equal to V naught sine omega t is this one, and current is ahead of net voltage by a phase of phi. So we will be writing it down as plus tan inverse XC upon R. Okay, this is the current flowing in the circuit, and it is ahead with the voltage, as you can see. Now we'll be discussing the average power here. Now to find out the average power, we need cos phi, and cos phi is also called as power factor. This is power factor. This is cos phi. Okay, and power factor is cos phi. So we know that tan phi is xc upon r. So cos phi will be r upon under root of x square plus r square. And it is z. So this is r upon z. And average power loss in this circuit will be Vrms into Irms into cos phi. So average power loss will be Vrms into Irms. Irms will be Vrms upon Z, and cos phi will be R upon Z. So average power loss will be Vrms square R upon Z square. This is the average power loss in this circuit. And if, see, we are actually will not be drawing the wave diagrams here, but in the very first case of combined circuits, I'll be assisting you to draw the wave diagram. But in the next videos of combined circuits, I'll not be drawing that diagram, because that is the phase is not known to us. So without any information of phase, we just know that current leads the voltage, but with how much phase it leads, we do not know. It depends on the value of elements, but obviously it can be drawn easily. I'll be showing you that if we draw the voltage first of all, then voltage will be sinusoidal like this, which we have already discussed it. This is V naught, and this will be minus V naught. And if we draw the current, so the current will be like this. First of all, let us see that current has a phase phi which is ahead of the voltage. So it will be starting from somewhere from this point and it will be going like this. Okay, this will be the current, and this value is unknown because we do not know the initial phase. Okay, guys, so this is I naught, and this will be minus I naught. This is time. Okay, so this was it in this video, and in the next video, I'll be bringing LR series circuits, or first of all, we'll be discussing the parallel RC circuit in the next video. Thank you.